For this question, we've been given a quadratic with unknown coefficients. We've been told that k is a constant, and this quadratic, when equated to 0, we have no real roots. So if I was to just draw an example, a quadratic, and this quadratic is not crossing y equals 0. Y equals 0 is indeed the x-axis. So as is no solution, there's no real roots. It's not crossing the x-axis. So that's basically what we're dealing with here. And this is obviously depending on the fact that k is positive. That's why you would have a shape such as that. Prove that k is greater than or equal to 0 and k is less than 3/4. What I would do first of all is think about what I'm actually trying to do here. I'm trying to show all of the values for which when I have k, the graph, my quadratic, does not touch y equals 0. So it must be this shape. I did say that, obviously you could have a negative quadratic, but if you have a negative coefficient on the x squared, then this would definitely cross. The other option you would potentially have is that if this is 0 and that's 0, then you end up with y equals 3. So obviously 3 cannot equal 0, so that's when you have a straight line. Now just to really illustrate this and for you to understand what's actually happening, I'm going to model this on GeoGebra. So here I have my equation, and this is minus 2 of, that's basically from my value here, from a value of k. So that's k x squared plus 4 times k, which again is minus 2 coming from there, times x plus 3. So if I play this, you can see what's happening in terms of all the different values that k can take. I've given a range in between -2 and 2. So here my graph is looking like this. As soon as my k turns positive, my graph looks like that. If I put in y equals 0, hopefully you can see what's actually happening here. So here I have two solutions. As I get to this point, about there, you get one solution. So if I just go back a little bit, I've got one solution around here, which is, as you can see, 3/4. It should be 3/4. So if I type that in, you can get it exactly where you want it to go. So that's one solution here, and you can see that solution occurs at -2, 0, coordinates -2, 0. If I carry on playing, there's no solutions, and then again you get two solutions. So there's definitely a range of values, and graphically you can see what's happening. I think that's pretty cool for you to sort of see and appreciate and understand. So I'm going to leave that there for now. Let's go back and show you where no solutions begin. So no solutions are going to be when k is less than 3/4, which I completely agree with. And then at this stage we get to k is 0, and when k is 0 it's a straight line, y equals 3, which is what we were expecting. And then if we carry on going, as soon as you get past 0, you can see that you will start having solutions because the graph shape is this way. So I think that's pretty cool to really appreciate and understand what's happening. So let's try and now answer algebraically what the question is asking us to do. And I'm just going to put this on 0.75. So how would I actually go about answering this question algebraically? Firstly, I would want you to realize that this is a quadratic. Ax squared plus bx plus c equal to 0. And we know that if I have a quadratic and it's equated to 0, that the discriminant b squared minus 4ac gives me a lot of information about the about this quadratic. If the discriminant is greater than 0, then I know I've got two solutions. If the discriminant is equal to 0, I know I've got one solution, one real solution. And if I've got the discriminant less than 0, you know that we've got no real roots. And that is the key part of this question, being able to realize that I need to apply this part of my discriminant knowledge to this question, no real roots. So if I go back to the question now and just write this on top, I have k x squared plus 4kx plus 3, and that's equal to 0. So you can very clearly see that my b is 4k. So b is equal to 4k. Okay, I'll just write that down for you. My a is equal to k, and my c is equal to 3. So now I'll just substitute this into the discriminant. Make sure you've got the inequality in there as well, so you can actually see what's happening. So b squared is 4k in brackets, don't forget the brackets, all squared, minus 4 times by k times by c, which is 3, and that is all going to be less than 0. 4 times 4 is 16, k squared minus 4 times 3, minus 4 times 3 is minus 12, and then I've got the k there, less than 0. And at this stage, the way I would actually handle this is I would just turn this question into an equation, because I think that really helps people to understand what's actually happening and solve for k. So I would do 16k squared minus 12k is equal to 0, and solve this like you would normally. So factorize 4k minus 3 is equal to 0. So here I've got a dot b is equal to 0, a times b is equal to 0. Either 4k is equal to 0 or 4k minus 3 is equal to 0. Therefore k must be equal to 0, or let me just quickly do this for you, k must be equal to 3 over 4. And now to answer the inequality part of the question, I would always want you to sketch a quadratic graph, something like this. You can see it's a positive, so I'm going to draw a U shape, and then I have these points to consider. Okay, this point here is 0, this point here is 3 over 4, and as that's less than or equal to, when is this graph less than 0? So what are the range of values here? And hopefully you can see that it is less than 0 when my values are in between 0 and 3 over 4. So that's 0. K must be greater than 0, which is that part there, and it must be less than 3 over 4. So that's that part done. However, we also have to consider what's actually happening when k is equal to 0 and when k is equal to 3 over 4. When k is equal to 0, you can see here very clearly that 0, 0, 3, 3 cannot be equal to 0. So that's obviously not correct, and therefore you can easily write your final answer as that. Now let me just quickly show you again. If k was equal to 0, graphically speaking, that's what you would get. And you can see here that this graph is not crossing y equals 0. And let me just show you on the other end, 0.75. Okay, when k is equal to 0.75, there is a solution, and that solution is very clearly there.